This is a breadboard. It's designed to quickly put together circuits. If you go into an electrical engineer's workshop, you'll see lots of these filled with wires and chips and resistors and capacitors. They work with breadboards to quickly put together a circuit, change out resistors, capacitors until the circuit does exactly what they like. Then they can send the drawing off and have a chip made that does exactly what this big circuit does. But we're going to do simple circuits, and we're going to use a breadboard to put the circuits together. And it helps us make electrical connections. So most of our circuits are being done in this area down here in the middle of the breadboard. The upper section and the lower section are designed to provide power to the breadboard. So usually we have, here it's indicated plus and minus, but you could hook them up however you want. But normally you would hook up the positive lead to your power supply here in one of these, and they're connected all the way across. All of these in the whole row are connected internally together. So here, if we plug in our power supply, our positive lead, and it's connected here, now I have power along this whole row. And I can tap in anywhere. If I want power over here, I can tap in. If I want it down here, I can tap in here. This is all connected together, and I have power along that whole row if I put power to this input. This one is connected to the other side, so that would be my ground or my the low voltage end of my power supply. And so my ground or my reference would be there, and that would complete my circuit to the power supply. So the upper row is connected all the way across, and the second row is connected all the way across, but they are, of course, are not connected to each other or anything else. Now down here where we're hooking up our circuit, these are connected in the other orientation. So these 5 holes, 1, 2, 3, 4, 5, are connected internally. So any 2 wires plugged in there are electrically connected, but they are not connected to any of their neighbors. So these 5 are connected internally, these 5 are connected internally, but those are not connected to each other. And these are connected internally, and these 5 are connected internally, but they are not connected across this center divider. Nothing on the upper half is connected to the lower half. That divider electrically isolates both parts. So these are connected together down here, 1, 2, 3, 4, 5. These are connected here, but they're not connected across that divider. They're isolated electrically from one another. Now let's assemble a simple circuit. If we hook up the high voltage part of our power supply to this part of our breadboard, the current will flow in to the breadboard here. So let's tap into that. Now I want to go through a resistor. So I'm going to pick one of my resistors. So you can see these 2 are connected. They're in the same column here. So they're connected internally to one another. And I'll go through another resistor now. And then through a third resistor. And then we'll go back to the power supply. So the current will come in from the high voltage part of our power supply. It would go through this wire. It's connected internally to the left lead of this resistor. So the current would come through the resistor in this direction. These are connected together. You can see right here, those are connected together. And the current would go through the second resistor. And these are connected together right here. Current comes through our third resistor, and that's connected to this red wire, which brings the current to this upper line, and that's connected to the low voltage end of our power supply, which completes the circuit.